Hi, good morning. Just a disclaimer aside, this is my first ever talk, so bear with me. I'm a little anxious. Thank you. So, we are today talking about all the work that has been done by Leonard. So, he already yesterday talked about UKIs and measured boot, and basically, and in this context, trusted boot means secure boot plus measured boot. So, I believe we are the first distro to implement it. So we had a lot of history when Leonard originally wrote about the brave new trusted world, but it kind of got lost in our Slack before we moved to a paid workspace. But this was when our lead actually talked about we might be the first to actually implement it as a distro. So just a quick question. So Talos is basically a custom distro based mostly for running Kubernetes. So that's it, at least we have it. And I think last week, Ubuntu also came up with a blog saying they are also implementing UKI-based updates and image support, which probably, but it's based on Snap, I guess. Anyway, so let's talk a little bit about Talos before we go into the details. So it's based on upstream kernel, but anything after that, the init and initrd and everything is just custom. It's all written in Golang, so after kernel transitions, it's all in Go. And it's basically just minimal stuff, like we just have containerd to run containers, Kubernetes, and that's it. And with the new implementation, it's all shipped as just a UKI, so we can just boot the whole OS as an ISO or Pixie boot or whatever. And Talos is also configuration driven, so whatever you want the system to do, you just specify it as a YAML spec. So this is like an example of how I specify the disk should have disk encryption based on TPM. And I also have an example where it adds a static key just in case you ever want to attach the disk and decrypt it from another system. And the other thing is it's kind of based on controllers, which we call COSI. It's called Common Operating System Interface. And it's kind of like Kubernetes controllers, but just custom built for Talos because Kubernetes controllers has a dependency on etcd and other stuff, but this is just basically so we can actually get information like what are all the addresses on a host, what is the mount status, if it's encrypted, what are the providers in use, etc. And this is like a high-level workflow. So you boot the ISO, the keys gets auto-enrolled based on all the measured values and stuff. So upgrades are seamless. That's it. And that's basically another way of showing, that's like our dashboard, the top one, which shows all the basic status. And you have a D message in the below, which you can scroll through. And the other part is where I show the security state. It actually prints up whether if it's secure booted and some fingerprints of the keys used to sign UKIs. And this is all fall under the UAPI group specification. So we have the bootloader specification, that's all the UI. The slides are shared already, so the links should be available, and the unified kernel image that Leonard spoke about yesterday. And this is like a Talos disk layout. What we did is we have like a big fat 32 UEFI partition. It's around like, I think 1.5 gigs somewhere, or 1,000 gig, I don't remember. Yeah, and then we have like meta and state is where we store Talos internal stuff, and ephemeral is basically /var. And one of the first things we did was moving away from grub when we wanted to do the secure boot with TPM. It made things easier. We don't have to write complex grub entries or parse it. The keys gets auto-enrolled if the UEFI is in auto-enrollment mode. And updating is pretty easy. You just drop in a new UKI, systemd picks it up based on the information, the P information from the uname section, the OSREL section, and we remove n-2 UKI, so upgrades are pretty seamless. So our grub had like almost 1,000 lines of implementation, and when we moved over to systemd, it was basically simple. And the last image shows how sdboot actually parses which OS to boot based on the OSREL information stored in the UKI. I just did an object copy of the OSREL section. And other thing is we did a partial implementations of UKI, systemd measure, and systemd cryptanol. Since Talos is based on Go and our toolchain is based on Musel, we didn't want to build systemd with a lot of patches, and we just copied out parts which made sense for us into Go implementations. So UKFI, so we did a minimal UKFI, which allows us to support building UKIs with Go. It still uses object copy, and I think with systemd 254, the upstream UKFI dropped it using a Python implementation of pparser, but we have like an issue to actually also remove dependency on object copy just to make it like a static Go binary. And the systemd measure was a little bit fun to implement because when I started working on it, I was reading through a systemd code. It had a dependency on a TPM being available to calculate. It was not using a virtual TPM or anything. Then while I was doing code, systemd 254 got in, then I saw the code and I saw, these hashes can be pre-calculated, and the Go TPM library by Google also has support for providing all the pre-calculating the signature, so it was pretty simple to actually port over. And the code is available here if anyone wants to take a look. Same thing with systemd cryptanol, we just took in the part that makes sense to implement TPM. So we have like a seal and unseal implementations, which basically reads the PCR sig and PCR P key values from the UKI and then does all the TPM based stuff. We have a little bit of deviations from the upstream implementation. So I guess systemd cryptanol allows even if PCR 7, which is the secure boot state, if it's empty, it will still enroll. We don't allow that because we don't want someone to disable secure boot and be able to unlock the disk. So that's it. The other one is we only do ECC keys because since we are a custom OS, it's just easier to only say have a TPM 2.0 which supports ECC key. It makes our lives easier. So we also don't need to persist the SRK because with ECC regenerating the key is pretty fast, so it doesn't matter. And we also store the token, which is like the encrypted blob you receive from TPM in a custom format, not the similar as systemd, because the Go library wants it in a different way. And these are the PCR registers in use, which we currently use, which is the PCR 7. That is where the TPM policy is bound to. So if your secure boot state changes, the disk won't get unlocked. And PCR 11, which is basically where systemd step measures all the information into. And this is like from the UAPI specification. So we use PCR 7 and PCR 11. And this is kind of like a high-level flow that goes through sealing, which basically we generate a random key on the host on the first boot. We validate PCR registers are not empty, because if it's empty, it doesn't make any sense to go through the flow. We calculate a sealing digest, which is based on the PCR 7 selection and the public key, the name of the public key that is in the UKI. So even if someone boots a different UKI, which is signed with a different PCR signing key, the disk can't get unlocked. Then we generate a primary SRK key, create a TPM object with a sealing policy, and then store that data in the looks token. The unseal is a little bit more complex, kind of say, because we have to read from the looks token. We again validate. Then we create a policy session based on the previous PCR 7 values. Then we regenerate the primary key. We load the value reader from the looks token into TPM. Then we create a digest, load the public key, verify the signature matches. We authorize the policy. Then we ask TPM to just unseal, which it does. Talking of future work, one thing we couldn't get working is the usual Talos upgrades previously were using KXig if it's available, because it just makes sense on bare metal because it's just faster. But with UKI, it's not possible because PCR states are only reset on boot. So it means when we can KXig, I actually did work around with KXig, but the disk won't unlock because the PCR values come from the expected PCR values come from the new UKI, which doesn't match whatever is in the current PCR state. But I think I started looking into what Leonard's talked about yesterday about PCR lock, and that seems to be an interesting idea. Yeah, and the other one, some kind of work we want to do is with TrustedBoot or measured boot, whatever comes with the init is trusted, but since Talos also brings up Kubernetes, it pulls random images from the internet like etcd kubelet, and we don't really have a way to verify, so we are thinking of looking into IMA attestation for those, probably pre-calculate the hashes and then sign those with a private key, which is already in the key that's already in the init so we can actually verify that random binaries that gets pulled in comes off, like you can trust it. And basically, the acknowledgements are mostly to Leonard for all the cool ideas. We also have an idea about system extensions in Talos, which is a little bit different, but the base idea is same. It's an overlay file system, and we also allow read-writable to run services. And then the TPM 2.0 guidebook, which was really, I think if anyone is working on TPM, probably should read that. It gives makes things really understanding to the TPM. Idiosyncrasy is much easier to understand. That's it. Questions? Probably I went over too fast. Questions? Sure.
Does Talos also do any remote attestation things to know?
Not yet, but we have some things in the plan.
Okay.
Over there.
Hi.
Not yet, but we have a SaaS product called Omni. So our kind of plan is to use that as a remote attester. So IMA, we have been looking into more IMA stuff. It's not there, but we have some kind of ideas on how we want to do it. It's just not there. We haven't really planned for it yet.
Okay, thanks. Cool.
But it's at least everyone talks about it once in a while. Else? Good, thank you. I can probably show how it works, maybe just a small demo since we have time. And it's all based on QEMU because it's just easier to test with QEMU. Yes. Oops. I can't get my password right.
Hi, yes, a question.
Just a minute. Yeah, sure.
Hi.
Yesterday we talked about credentials extensions where you can, through QEMU, just import credentials into systemd at boot. How does Talos handle? Do you have a way to handle the injections of secrets inside Talos?
Not yet. The only way is kind of basically specified as static in the machine config, which is the configuration-driven part, but we are open to more ideas about how we could actually pass it as part of the UKI. So we have something that's coming up called an image service, which allows you to build UKIs on the fly with whatever customizations you need. So that could actually pave a way to provide encrypted credentials, and the TPM can then unlock it or something. It's not there yet, yeah. So I'm just bringing up a Talos cluster with QEMU, so it uses something called SWTPM as a TPM emulator. And for the first time it boots, it actually, the keys gets auto-enrolled from the UKI, which just makes it much easier with system deboot, because we had some customers with some weird hardware and it was like very painful to manually enroll the keys. And when we just use system deboot, it just did it. It was much easier. And this is where it actually, I don't really have nothing to show really in the demo. It's all trivial, not trivial, it's just all comes up together. There's nothing in the logs or anything to see, rather than I can show that it's actually encrypted the disk. Probably I can search for. Yeah, this is like where we extend the PCRs with the faces. So we have like some faces that extend the PCRs as systemd PCR face does. So after Talos boots up and unlocks the disk, nothing else can decrypt it. And probably it's just still booting up, but I can probably show. So it's secure booted, like based on our controllers. So security says it's secure booted, and I can probably bring up a dashboard, which also shows that we had two partitions, which is state and an ephemeral, and the state is encrypted just with the TPM data, and the ephemeral is basically encrypted with TPM and a static key. And that was passed in when I actually launched the cluster, saying for the system disk, ephemeral disk, for the slot 1, use a static passphrase, and for slot 0, it actually uses a, yeah, I can actually pull this up, system. So this is where the configuration says the state partition should use TPM for the slot 0, and if I scroll down for the ephemeral, the first slot 0 uses TPM, and it's just a static key as a demo. That's it. That's it. Thanks.